All right, I'm going to start everything off. I would like to thank you for taking the time to attend today. Hello, my name is Lance Zurich, and today what we're going to do is we're going to take a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Now, both of these sets are designed for conducting a project-based class, and this is where students will be required to design and build a series of original prototypes, which are all going to be based upon their own research and activities. And each of these sets includes standards-focused curriculum, which was created especially for Studica by noted educator and STEM expert, Tom White. And today we're going to start off where so many technology-focused presentations for education start these days, and that's with the skills gap that exists. Now, when you hear someone reference the skills gap or talk about the need for better STEM education in the schools, STEM, of course, being an acronym for science, technology, engineering, and mathematics, well, what they're essentially talking about is the urgent need to prepare our students with the background they need to successfully compete in the job market that they're going to be graduating into. Now, in the employment market that once greeted our grandparents, or even our parents for that matter, a good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the technical aspects of the work could be learned on the fly. But now, students really have to be prepared to enter a world that is increasingly focused on programming, increasingly focused on automation, on IoT, and rapid advances in almost all aspects of technology. Now, in short, students must be able to demonstrate technical literacy and aptitude if they really hope to compete and succeed. Now, this is, of course, why so much of the emphasis in education over the last decade has been on developing STEM skills. Now, every new advantage we enjoy, and this can be the tablets and the smartphones that we all use daily, the list could go on, but all of these things were created because of individuals who helped to make those advances. Countries all around the globe right now, countries like China and India and so many others, are making major strides in developing new technological advances and preparing their own students to take their place in the future workforce. And here in the United States, we really also need to prepare the next generation of students with the skills, the mindset, and the habits that are going to enable them not only to secure jobs, but also to be part of the next wave of advancements that we're going to rely on to stay competitive on the world stage and really to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like the one we're having today is already in agreement about the importance of STEM and technology-focused programs, what we're going to do is we're going to move right along to the main topic, which is, of course, mechatronics. Now, mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, on control and mechanical systems, on robotics, the Internet of Things, and computer science, all of which are extremely important subject areas for students to be exposed to, and all skill sets that are highly prized in today's technology-focused job market. Well, just how prized? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they need to start developing the habits and the career focus as early as possible, in high school, if not even in middle school. Now, the dilemma for educators, whether in the classroom or the homeschool environment, is finding ways of introducing this kind of subject matter to students in a way that gets them interested and involved in the learning process, and not just memorizing obscure facts or ideas just to regurgitate them for a few tests, then promptly flush it from their memory. No. To best help students to be successful and to really encourage them to consider pursuing further education in subject matter areas like this, educators need to be able to present the material in a way that makes it relevant. And this means ways that help to answer those eternal student questions of why do we need to know this? Now, it also needs to be engaging. And it's got to be engaging in a way that holds students' attention better than rote textbooks and lecture presentations do. And it has to be something that has visible real-world applications in which the student can get involved in doing things hands-on. Now, it's with this dilemma in mind that we created the Studica Mechatronics program. Now, these two special sets, one of which is designed as an introduction to the world of mechatronics, and one of which is intended really to be a standalone class dedicated to the subject of mechatronics, each of these sets were created to provide all of the materials in one place, everything that educators would need to enable them to offer a project-based class that is relevant, engaging, realistic, hands-on, and of course, which is crafted to meet most current academic standards. Now, each of the two Studica Mechatronics program sets has its own detailed day-by-day curriculum document, which again was created especially for Studica by noted educator and STEM expert Tom White. Now, the curriculum comes as a downloadable PDF, which is available for free with the purchase of each of these sets, and in whatever quantity I should add as well. Now, this curriculum is designed to align to the most widely accepted academic standards that are currently in place in the United States. The curriculum is also designed for offering a project-based learning experience. And what this means is it means solving the problems that arise in each of the units. To do so, this requires the students to be actively involved in the research, actively involved in the design, the trial and error experimentation and activities, and in the building of actual working prototypes that will provide the required answers. And students don't do this alone either. They're going to be asked to work in small groups or teams, if you want to speak of it that way, but basically small groups of 4 students each. And what this does is it helps to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And by soft skills, of course, we mean things like communication skills, teamwork, adaptability, problem solving, and of course, leadership. And finally, with the exception of some very affordable programming software, each set includes all of the physical building materials each group will need to enable it to address all of the design projects presented throughout the course of the curriculum. Now, this curriculum is designed to enable teachers of all sorts of backgrounds, and this means even teachers from non-science or non-technology focused disciplines. It's designed to enable all sorts of teachers to have the information they need at hand to properly prepare them for conducting the activities and to increase their own comfort in presenting this material to their students. Now, the curriculum is designed to be clear and easy to follow and to provide a clear roadmap for student learning. Now, various supplemental materials are included as well, both in link form throughout the curriculum and also at the end of each unit. And there are also special tutorials on familiarizing students with the building system they're going to use to address the projects presented in each of these units. The units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging real-world style scenario where students must work together in small teams, again, these groups of 4 students per group, and they're going to work together to create a solution to these problems. The project units each contain embedded academics, and at the end of each of these units, these project units, the students will be required to make a formal presentation of the prototype they have created to address that unit's real-world scenario, and they have to explain their reasoning for doing so. Now, there's a technical literacy task driven by each of these projects. As students work to address each project, they will acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are acquired through the carefully designed enabling activities. Again, as required by each project, students will be asked to create original prototypes and any required programming-based solutions, and also they're going to be asked to maintain detailed documentation during the entire process. Now, as I mentioned a couple times in this presentation, the curriculum that accompanies each of the Mechatronics program sets was created especially for Studica by a man named Tom White. And of course, you see Tom smiling over here on the side of our screen. Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s, and he's known for designing programs for educational institutions and for industry use. In fact, as an expert in hardware and software integration, Tom has been pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. The standards addressed in the Studica Mechatronics programs are the most widely accepted standards currently in place in the United States. Now, these include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K-12 and the standards for technological literacy. And as I mentioned earlier, the programs are designed to be project-based. Now, this approach helps to answer that eternal question, of course, as I mentioned before, why do we need to know this and where are we ever going to use this? And these are questions that too often arise when students are presented with technical subjects that might just come across as too abstract in their purpose. Instead, here they see firsthand why these things are necessary and where they're useful. The concept of working in the small groups to solve the project problems also helps students to develop the high demand skills that employers look for. Again, these are the soft skills, things like communication, analytical skills, quantitative skills, flexibility, adaptability, and problem solving. Now, in this project-based format, students are integrated, or subjects are integrated. The math is integrated with the reading and the writing and so on, which is ideal for STEM education. Also, because of the manner in which students must approach each of these projects, with the research that's involved, the testing, and the group give and take, just to provide a few examples, this allows for a much deeper exploration of problems than traditional teaching methods might allow. The projects themselves are presented in each unit are also designed so that if you have several groups of students working on the same project, as we would hope you would have, you should see variations in their prototypes and their solutions. Now, this can be because of creativity on the different part of the different student groups. It can be differences in the research that they do, the approaches taken by each of the groups, whatever it might be. In any case, students can see firsthand that problems can have many different answers and that often there is not only one right answer. Each project in the curriculum presents students with the opportunity to plan, to organize, and conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge they need to draw on to complete each project just in time. And students will be required to do extensive research as they complete each of these projects, research that is utilized in the design stages, the prototyping, the testing, the evaluation, and the redesign phases of each of these solutions. Again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students at a time. The team approach, as stated before, is designed to help promote the soft skill areas, again, communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach. Essentially, what you can do is you can just divide the number of students in your classroom by 4 to determine the number of sets needed for each class. And once again, everything you need to conduct the program, with the exception of the programming software, which can be purchased in either single user licenses or very affordable school site licenses, everything else is included in the box. And we're going to talk about the software in just a little bit. Now, access to the free curriculum download is included with the purchase of each set. Again, whether you buy 1 set or you buy 100, you get access to that curriculum download immediately. Also included are all the building materials which students are going to use in the creation of each of their prototypes. Now, these building materials are from the unique Fisher-Technic building system, and among the components included in each set are 2 robotic controllers, like you see on your screen now, and 2 power supplies. Now, this may bring up a question, since I just mentioned Fisher-Technic. What is Fisher-Technic? Well, for those who may not be familiar with Fisher-Technic, it's a flexible and innovative construction system. Now, unlike other popular construction sets that are designed to simply stack, Fisher-Technic was created with more of an engineering mindset. What I mean by that is that the core building block in the Fisher Technic system, an example of which you see on the screen right now, is unique because it allows attachment from all 6 sides. And because of this, it allows for almost limitless design possibilities. Now, many of the other parts that are designed to work with this system are designed to slide together and lock in place. And there are hundreds of different parts available, very unique parts for unique functions that will also help students to address very specific engineering design needs. Fisher Technic was created in the 1960s by German inventor Arthur Fisher, who's noted for countless innovations used in both the construction and the automotive industry. Now, Mr. Fisher, at the time of his death, which was just a couple years ago in 2016, at that time, he held more patents in his name than Thomas Alva Edison had amassed during his own lifetime, which I think is pretty impressive. Now, besides Fisher Technic, Mr. Fisher was also the inventor of synchronized flash photography, which was back in 1949, and he was also the creator of the expanding nylon wall plug, which is used in conjunction with a screw or bolt to help anchor heavy objects to walls. I'm sure we've all used those. His company, the Fisher Group, employs thousands of workers worldwide, producing many variations of fastening devices used in building construction, as well as components used in automobile manufacturing, and they also provide consulting services related to automated processes. Now, with all that being said, let's begin looking at each of the 2 individual sets. We'll start off with the Studica Introduction to Mechatronics Program set, or for those of you who might prefer acronyms, you can refer to it as SIMP. The set is designed to help provide a well-rounded, comprehensive introduction to the core concepts of mechatronics. Each set, again, includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, which was, as I mentioned before, written by Tom White. The curriculum itself contains enough activity material to fill approximately 45 academic hours. Now, with this in mind, we really recommend this set for insertion in regular related class activities. It could be used as a short class unto itself. It could be used for after-school program use, or of course, for those who are homeschoolers who are looking for a way to approach this type of subject matter. Now, the curriculum created for the set is standards focused. Again, using the academic standards most widely recognized in US-based education today, and it's designed to offer a project-based learning program. The set is designed for use in middle or high school classes, or again for addressing the same grade levels in a homeschool environment. Each set contains a collection of over 700 Fisher Technic building components, and this includes everything from gears to wheels, axles, blocks, sensors, and so much more, as well as 2 robotic controllers and 2 power supplies. Again, robotic control software is required and sold separately, and we'll talk about that in a minute. The curriculum for the Studica Introduction to Mechatronics program set consists of 6 project units, and they are as follows. There's a unit on sketching and documentation, one on simple machines, another on mechanical systems. Then we address basic electricity, unlike what my slide says there, basis, need to correct that. It addresses conversion and storage of energy, and then we have a unit on an introduction to control systems. Now, there are also activities included to address the following areas that come up during the course of the curriculum: sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using software and robotic controllers, working with sensors such as the digital switch and the digital photo transistor, working with open loop and closed loop programming, with digital branching, working with analog sensors like the photocell LDR, working with analog branching, and working with analog sensors such as the NTC resistor and the potentiometer. Now, before we go further into the structure of the curriculum, we're first going to look at what's covered in the second set. The second set is the Studica Teaching Applications of Mechatronics Program, and in this case, for those again who like acronyms, the acronym for this set is STAMP. The set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. This set comes with access to the free downloadable 401-page curriculum document, this time entitled Mechatronic Applications, again by Tom White. The activity material in this curriculum document, when used in conjunction with the components of this in this set, is designed to fill approximately 180 academic hours. So essentially this set, about 4 times as much academic material, essentially this set can be seen as a more expansive version of the material touched on in the previous set, and it's designed for those educators who are able and willing to dedicate a daily class period of approximately 50 minutes a day, 5 days a week, or the equivalent, each week for a full academic year. Again, this set is designed for offering students a standards-focused, project-based learning experience, and it's designed for use in middle school, high school, or again for addressing similar grade levels in a homeschool setting. The materials in this set consist of a selection of over 1,200 Fisher Technic building components. Again, this will be, once again, a wider range of gears, blocks, sensors, axles, and lots of other great parts, as well as 2 robotic controllers and 2 power supplies. The software, as you've heard me mention before, is separate, and we'll talk about it. Now, there are going to be twice as many project units included in the Studica Teaching Applications of Mechatronics Program set as there were in the set we previously discussed. And these will include project units on sketching and documentation, simple machines, mechanical systems, basic electricity, and then project units focusing on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided for various activity materials for students to utilize. And this includes sections on the following: sketching, linkage diagrams, schematics, Ohm's law and power, flowcharts, using the programming software and the robotic controllers, working with open loop programming, working with sensors such as the digital switch and the digital photo transistor, working with closed loop programming and digital branching, learning about logic gates and combinational logic, edge triggered versus level triggered, learning about pneumatics, variables, positions, learning how to record positions, creating a graphical user interface, learning about analog sensors such as the photocell LDR, the NTC resistor, the potentiometer, and working with data. Now that we've had a look at how each of these 2 sets differs and the specific subject matter covered by each, let's now look at exactly how the curriculum itself is structured. Now, both versions of curriculum share the same format when it comes to the structure of each of the project units, and as already discussed, each version is going to include tutorial materials, each version is going to have activity materials, standards, and of course, supplementary materials. Now, in each case, the curriculum is also designed to be turnkey. And what we mean by that is that besides the elements I just mentioned, each unit is designed in such a way as to enable teachers from all types of backgrounds, and again, this is whether it's a non-science background that you come from, a non-technology focused background, still, you should be able to quickly become comfortable with delivering the material simply by reviewing each section before you present it in class. So for each of these units, I would say if you read over the material, it should provide enough guidance and direction that you should feel fully confident conducting these class activities. Each unit in the curriculum is going to include the following sections. It's going to include an introduction, a section stating what the purpose of the project that you're going to be doing, what is the purpose of it, an area addressing the concepts, an outline of what's going to be covered, the standards that are going to be met are all addressed here, assessment rubrics are provided, the essential question is put forth, and the student scenario, the real world scenario, is also given. There is a daily plan, there are vocabulary words, and there are resources. Now we're going to look at each of these sections just a little bit closer. Each unit starts with an introductory section and the purpose of the project. Now, just as you would likely gather from that name, this is the section that provides a brief description of the topic that's going to be explored in the coming days and the coming activities. And this is also the section that seeks to clearly spell out to students the answer to that eternal question I brought up. Why are we doing this? Well, this is where you're going to tell them. The next section focuses on the concepts to be addressed in the particular unit. And these can be thought of as the broad ideas that are going to be explored in that unit and the core information that students should take from this project that will be essential for them to understand and utilize not only today, but also hopefully to draw upon as they move forward in STEM fields of study, and of course we all hope STEM-related careers. After this, we get into the outline. And in this section, we drove down more specifically to what will be addressed in the unit itself. Now again, as this example shown on the screen now is taken from a unit that addresses aspects of programming, you're going to see that we touch upon areas such as the methods for writing programs, for example, flow charts and word problems. We're going to get into things like program characteristics, again, things like open or closed loop, branching, whether it be digital, analog, subprograms, and so on. The next section of each unit focuses on the specific academic standards that are going to be addressed by the project and by doing all these activities. Now, as you will see, the standards include things like college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history and social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for K-12, and the standards for technological literacy. Each project unit, as I mentioned, also contains rubrics. And this is going to include both the rubrics for the specific project unit being covered, along with general rubrics for literacy tasks. Next up is the essential question. And again, this can be thought of as the big picture question that will be focused on in each of the smaller individual activities that they're going to be addressing in the unit. And of course, all the aspects of the larger project which students are going to be asked to complete in this section. After this, we get into the student scenario. And the student scenario is where the specifics of the project to be addressed are really finely detailed, all of which is presented in the context of a real-world style scenario where students are going to be presented with a problem that they must work together in groups to solve. Now, this problem will require students to design a unique and original answer, and it's usually going to be in the form of a working prototype, along with whatever programming might be required. Now, if you look closely at the student scenario that I have on the screen right now, you'll see that the project being discussed in this unit has each group of students taking on the role of a design team, which is employed by a firm that manufactures garage door openers. Now, in this particular case, students will have to design a specific type of control system for a new line of garage doors. The manufacturer's requirements are all spelled out here, such as in this case, the use of limit switches, meeting certain safety codes that require a method for sensing, for example, if anything is in the way of a closing door, and also the incorporation of an automatic light. Now, as discussed previously, each group of students will be tasked with creating both a unique and original prototype, and in this case, of course, that's the garage door opening system, as well as the programming needed to control that prototype. Now, along the way, they will be required to document the entire process in both a design notebook and a digital engineering journal. And they have to note all their research that they go through, all the trial and error experiments that they might perform. They have to keep copies of all design sketches, any revisions they make, all of that gets kept in their journals, and so on. And at the end of each of these project units, each group of students will be required to make a formal presentation in front of the class during which they demonstrate their prototype and the programming in action, much as they would be required to do for an actual employer or client in the real world. After this, we have the daily plan. And this is the section that spells out clearly, both for the students and the teachers, what's going to be expected of the students and how the teacher is going to conduct that day's classroom activities and what specific subject matter, of course, will be covered. Now, some days may involve discussions. Other days may involve more research or, for example, building small projects that help provide the building blocks that students are going to draw on to complete their own larger project as described in the student scenario. But in short, you can basically think of the daily plan as a roadmap for teachers and students. Now, you'll also see that along the way that as different aspects are addressed in each day's activities, such as, for example, when we get into discussing a design notebook, what's required for a design notebook, how to use the control software, working with the controller, or working with flowcharts, or what have you. Whenever things like this come up in the course of the daily plan, there are links to sections that will provide further instructions and information on each of these areas. So this way, students have any questions, they can just click on that link, find out how to use the controller, find out what's required for the digital engineering notebook or what have you. It's all easily accessible, and it keeps them, once again, right on the page. Now, at the end of each unit, after the daily plan, is a section containing vocabulary words, and these are going to be important words and terminology introduced during the project unit, as well as a selection of important resource materials. Now, these resources can contain a mix of different types of material. They could be carefully vetted websites and video links. It could be PDF documents and PowerPoints and what have you. It's all going to depend on the unit itself, but you'll see these types of materials pop up in there. Now, besides the project units, each version of the curriculum also includes a section devoted to learning how to use the Fisher Technic building system. And this includes information on how the parts fit together using the pin and groove assembly method. It includes a section identifying the various types of parts being used, from the various types of girders and blocks to the different types of axles, the different types of gears, rivets, and so on and so forth. Now, students will also get to build a very basic sample model just to help familiarize them with the system before they move on to the larger projects that are given in each unit. And as learning about and maintaining proper documentation is, again, one of the areas being stressed in the course of the curriculum, there is a section that details just what defines each type of documentation as listed on the screen now, and what is going to be required for each of those documents. And as the process of conducting project-based class activities might be unfamiliar to some teachers, there's also a section that discusses specifically project-based STEM education and its benefits. So just to review everything again very briefly, this time with pricing though. First, we have the Studica Introduction to Mechatronics Program set, designed as a standards-focused project-based introduction to the core concepts of mechatronics. The program is conducted with the use of a highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted educator and STEM expert Tom White. The curriculum, when used in conjunction with the materials included in each set, will provide educators with enough activity material to fill approximately 45 academic hours. It is again designed for those educators who wish to offer short classes, after-school programs, or for homeschool use. The standards-based materials designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these specific grade levels. The physical materials in each set include a selection of over 700 components from the Fisher Technic building system, and again, this includes everything from the sensors, blocks, gears, and much more, which will be used to construct the prototypes required in each project unit of the curriculum, as well as 2 robotic control units and 2 power supplies. Software, of course, is required, as I've said several times, and is sold separately. Again, each set is designed for use by a group of 4 students at a time, with pricing starting at just $699 for a single set, and classroom size quotes for 20 students and up are available upon request. The other set, again, is the Studica Teaching Applications of Mechatronics Program set, and this set is designed as a more comprehensive, in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics. The program here is based around a highly detailed 401-page curriculum document entitled Mechatronic Applications, again, written by noted educator and STEM expert Tom White. The document, like the one with the previous set, is a downloadable PDF document which can be accessed with the instructions included inside of each box. Now, when used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity and material to fill approximately 180 academic hours. Again, this is designed for those educators and homeschoolers who are willing and able to offer a daily dedicated class period of 50 minutes per day for 5 days a week or the equivalent on this subject matter for a full academic year. Again, the standards-based materials designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics for these grade levels. Each box contains an assortment of over 1,200 components from the Fisher Technic building system, including, again, blocks, girders, gears, sensors, axles, and a whole lot more, as well as 2 robotic control units and 2 power supplies. Software, as I keep mentioning, is required, sold separately, and is available in both single user licenses as well as very affordable unlimited school site licenses. Once again, each set is designed to provide enough materials for 4 students, with pricing for a single set starting at only $799 for 1 set. And of course, classroom size pricing for over 20 students is available by quote upon request. As of course I keep mentioning the software that's required, let me address that real quickly as well. The software in question that's used with these sets is the Fisher Technic RoboPro software, which is graphic programming software. And what graphic programming software is that it means that it uses a flowchart style design, and in this case it uses various icons which students arrange and link to create the programs used for each of the models in these projects. It's ideal for teaching the fundamentals of programming to users of all levels. It's very easy to use, and even if you are familiar with other types of programming, you'll see that the aspects are the same, but especially for someone who's never done programming before, this is very user-friendly. Now, pricing for a single user license of RoboPro is only $36 per license, and an unlimited single site school site license, meaning that you can have unlimited users at a single site or building with this license. That means 1 computer, 100 or more if you need it. And the cost for this site license is only $120 per site license. And please note that these are not subscription prices and they're not annual licenses. These are non-expiring licenses you can access as long as, and you can use it and access it as long as you have the software disk, which we're going to send you, and as long as you're able to install it on a compatible Windows-based desktop or laptop computer using Windows version 7, 8, or 10. And I would mention that, of course, as these things are upgraded, Fisher Technic provides upgrades on their website. So at this point, we will open up the chat windows to any questions you might have. If you look on the Zoom toolbar, there should be a chat window. I believe it's at the far left of the Zoom toolbar under the ellipses, or in the middle of the toolbar should be a question and answer window. Either one of those, you can open it up, and if you have any questions, you can feel free to type them in. Taking the opportunity to have a drink of water because I'm quite thirsty after talking for that long. Okay, since I don't see any questions, let's see. So if you're ready to take the next step, if you're ready to request a quote, or if you'd like to speak to the dedicated educational representative for your state to find out more about either of these 2 sets or any of the other educational solutions we offer, you can simply call us toll free at 888-561-7521. Or if you like, you can also email us at info@studica.com. Now, if you do have any specific questions about anything that I've discussed or brought up here, or anything I haven't discussed, or if you have questions about, for example, the Fisher Technic building system, or if you'd like to know more about the Fisher Technic education-focused solutions for teaching about STEM and technology, you can also email me directly. My email address is lance.zurek. You'll see it right up on the screen, lance.zurek@studica, studica.com. And if you email me, I will be happy to answer any questions you might have. So on that note, I'd like to thank you very much again for taking the time to attend today's presentation. We look forward to speaking to you soon, so have a great afternoon. Take care.